version you also connect because they use SAS.
Thank you.
Awesome. So next speaker is Preet from EXL.
Hi, good evening everyone. So, firstly, thank you Alex, and have a huge round of applause for ourselves because we made it over here in this winter, over here, on a working day. So, today I'm going to talk about the Medallion architecture. How many of you have heard about the Medallion architecture? I'm sure most of you have. And the Unified Data Quality Framework in healthcare with Databricks. This session is less about Databricks, more about healthcare. So I'm Preet. I'm currently based out of Boston. I came for this event, and I'll be coming back again today. I enjoy solving healthcare problems using Spark. I recently started learning Databricks. Looking forward to learn more from you guys. And I'm working as a manager at healthcare in the healthcare analytics at EXL. So what we do is reach out to the healthcare leaders across US, companies based in insurance and like pharmaceuticals, clinics, and help them solve like big data problems. And pursue a master's in data engineering at Northeastern University. So there are three things we're going to discuss today. What are the challenges in healthcare? Healthcare is huge, so we are going to cover a specific segment of the healthcare, not the entire healthcare. And what is metadata-driven framework? Has anyone heard about metadata-driven framework? Okay, that's good. We're going to learn today. And what are the Delta Lake features? You can also consider Databricks features or Delta Lake features. How those features help solve some of the problems. So, right the day when a baby is born, the carbon footprint or the digital footprint gets entered inside an EMR. How many of you have worked on EMR? It's not the AWS EMR. We're talking about electronic, so medical records. So if you have visited a PCP, right, a provider, you might have seen the doctors typing something on the screen while you are talking. So that tool is called an EMR, right? So your lab results, your entire medical history, your diagnosis, everything will be stored in that software. So not just EMRs, but also your insurance, your wearable devices which you're wearing. So all these tools, everything is capturing the healthcare data across the globe. 30% of the data is in healthcare, but 70% of it is unstructured. How many of you know Aetna Health Insurance? It even existed even before Oppenheimer invented atom bomb, right? So since then, Aetna Health Insurance exists. So initially they were writing all the stuff on the papers. Later then they started scanning, and after that everything became digital, right? So they have like 200 years of data. So now the challenge is not about collecting the data anymore. So it's about how to use it to give a personalized care to a patient, right? So a lot of challenges in healthcare. I'm going to present today a use case which I worked on recently. So let's consider a company called ABC Health. It is an integrated provider group company. So what is that? So integrated provider group company collect data from different EMRs, companies which collect your data when you visit a PCP, nurse, or anything. And they try to collect the data from all the EMRs and gather it in one place and try to derive some business outcomes. For example, improving the revenue, like the RCM. They can also help in predicting the disease before, like a chronic disease. For example, let's say these 3 EMRs are of nephrologists, right? So they can help in identifying or finding the chronic disease in kidneys way before when it can occur. You can also take example of diabetes. So that's what these integrated provider companies do. They see the cost, like the capex and the opex of hospitals, right? So, and so to do that, you have to create a unified view of a patient. Imagine you are going to a PCP and you are suffering from chronic disease. Let's say you just Google somewhere that I'm suffering from this disease, what are the stuff that I can do, and you visited PCP. After that, you are claiming some amount. So all this data gets gathered into one place, and that's EMR. So now, in this use case, this entire presentation is around this use case. So let's understand. So currently, the first EMR, EMR1, is already integrated with the ABC Health Group company. Now, what they want to do is they want to integrate the other two EMRs as well in the same system. Now, what you see, those three medallions, that's the medallion architecture. Databricks coined it in 2020 just to look like a bit cool, but the same concept was derived by Kimball in 1990s, right? It's not something new. Now, and what this company wants to do is they want to collect the data in the bronze layer, improve the quality gradually in the silver layer, and want to create some dimensions and fact tables in the gold layer. And after that, the data scientists or the ML people want to create the holistic view of the patient so that identify the disease at an early stage, or they want to create some dashboards or for ad hoc queries. So this is the use case that we want to build, right? So now, yeah, and the first EMR is in SQL Server, the second EMR and the third EMR is in Kafka and Snowflake. So I don't want to emphasize on these tools. The thing is, it's batch and streaming. Now, we want to bring the data from batch and streaming together and want to create a single pipeline. So let's understand what are the challenges that we can face. Now, the biggest challenge in healthcare, there are two challenges. The first one is data interpretability and data integration. So it's not like you are using a Tableau and you have 15 places you can connect with. This is a healthcare data. It's very difficult to connect the data from different places, make sure the tool is having the connectivity capability from different places, and bring it at one place. So this is the first challenge. Second is customization, adaptability. EMRs are private vendors. They manage data on their own. They have their own data validation rules. They have their own nomenclature. And there are no such global rules that they follow, right? So now bringing this data at one place, all having different business logics, is very difficult. Data security and privacy. There are companies who lost some PHIPI data and had to pay billions of dollars. So data security and privacy is very important. If there are some offshore people you want to share the data with, make sure it's encrypted. Even if in the lower environments, the data has to be encrypted, right? We'll discuss more in the next slides. Query performance. The data scientists, they cannot wait. They want everything quickly. So the biggest challenge is to scan the metadata quickly. It generally becomes a bottleneck, leading to slower query performance and also the joins and stuff. So there's another issue. Data quality. There used to be a lot of duplicates that you can come across. Even the data types are not same across different EMRs. And the another problem which I told about streaming and batch. Even if you use Lambda architecture, you still end up building two different pipelines. But the challenge is you want just single. Let's understand it more using this example. Each EMR has like hundreds of tables, and each table has more than 100 columns. For this presentation, for the limited time, I'll just take an example of an appointment table and just few columns. Now, EMR1 is already integrated with this company, ABC Health. Now, they want to integrate EMR2. Generally, the integrated provider company deals with 10 EMRs. I'll just take an example of 2 right now. So, as you can see in the bronze layer, so in the bronze layer, we have the historical data. There are a lot of audit rules for the healthcare companies that they have to store the historical data for past 10 years or 5 years. So this is that layer, and you can never delete the data. You should only append incrementally in the bronze. And as you can see, the EMR1 and EMR2, there are different tables coming from different EMRs. We haven't did or from a union or merged together. In the silver layer, we are trying to gradually improve the quality and bringing the data from both the tables into one. In silver, a lot of merge, join, and like a lot of utility columns which I haven't mentioned here, which helps to track like in which batch the data is coming. But there are some challenges over here that we can see. So the first challenge is the table name itself. Some people use in caps, some in small. The column names, sometimes they add spaces in the column names, some put underscore. There are some columns which are same across both the EMRs. There are some columns which are not present or specific to some EMR. Even the data type is not same for the columns that are present in both. So there are such challenges that you come across in healthcare. And if you see the silver layer, where they are harmonizing the data types and the data coming from both into one, and they have to make sure the schema is enforced and the evaluation happens in one, like it's enforced, like we cannot change the data type going on, right, going forward. And the goal here is the place where we create dimensions and fact tables based on whatever the requirements of the ML and the AI people is. Now, having understood the challenge, let's understand the metadata-driven framework. Let's say if you want to implement this in whatever system, let's say you're using RDBMS or data warehouses, imagine how you write the code. Let's say there are hundreds of columns or 50 columns, let's say from each table there are hundreds of tables. You hard code these column names. Let's say when if you're hard coding, these columns are not present in all the EMRs. So, but still you have to create a unified layer. That is a challenge, right? So you have to make sure the columns which are not present are nullified. You have to also cast the data types. And what if the column is deleted in the upstream? You are collecting from the vendors. What if they added a new column or renamed the column or removed the column? So you have to again go back to your code and delete those columns manually. What if you're using that table across hundreds of notebooks? That's a manual exercise. So that is why we want to do something that's called as metadata-driven approach. Again, this concept is also pitched by Databricks in 2020. So the main intention of this is to use the same code again. So in this project, we had created a single metadata-driven code, and that was used for more than 150 tables to bring from bronze to silver, and scalable. So our target after this 20 minutes of presentation is to learn how can we add, let's say, 15 EMRs tomorrow. We don't have to worry about the code. So think of it like a table in which you are writing the source table names, the target table names, the data types of the target table. You're also mentioning what are the data quality rules that you want to apply on these columns. Added columns with the minimum, like the granularity of this table is column level. You can also mention what are the nullables, which column needs to be null, which column is an identity, which column has to be a partition. So all the rules which you write in the EDL and the DML is defined in the form of a table. Let's understand this with an example. In the same example, we want to do a union of the two tables into one. So over here, as we can see, the first thing is we have written the data type of the target columns that needs to be enforced. Second is the null checks, which columns can contain nulls or which cannot. Imagine creating 200 tables, you have to write data definition language for 200 tables, and writing the nulls and not nulls. It's a tedious job. Over here, it's kind of a table format, just define which columns can be null or cannot be. Apart from that, sometimes what happens is, let's say you are migrating data from one table to another table. Here there are 100 columns, but here you only moved 50 records from 100 records to 50. So the row count is also a challenge sometimes in the data quality. So this can also take care of the row count. What about if there are some custom SQLs or business checks that you need to do for some columns particularly? The slide is small, so I wouldn't add more attributes, otherwise there are like 10 to 15 attributes more. So it covers data quality checks, which you'll see the next slide, and also the masking. imagine you have PHI data, and it has to be masked in such a way that the value, the tokenized value remains the same. If the patient ID is 1001 and you encrypt it to, let's say, a hash key, all the records across all the tables, 1001 should define the same hash key. So what this metadata helps us to make sure, like the control table drives the schema standardization without hard coding it anywhere. So if you want to add another EMR or more tables, you can just use this approach. Let's understand the masking and the data quality. So let's say I have a patient's table over here, and it has to be masked in different way. Names, SSN, email address, everything has to be masked in different way. So you can just create the masking functions for each of the columns. You just write it besides the column name. Similarly for the data quality, whatever data quality checks that you need to do on each of the columns, just define those rules. Just write this custom rules in those columns. I'm not going to talk about the code on how to write this, but it's about the metadata-driven framework, so that code will actually scan each and every table and each and every column and try to build a custom approach, like a dynamic approach. Data privacy, the biggest risk in healthcare. So in Databricks, there is this beta feature, which is data classification. Let's say you have more than 10,000 columns across hundreds of tables. It takes manual effort to identify PHI PII. Now, just by reading the column names, you don't know if the data is PHI PII. So they have this feature which helps us identify which are the PHI PII columns. Another thing is you can create the masking functions in which you can define the rules. For example, in the production, you want the decrypted data. In the load dynamics, you can have the encrypted data. Whatever rules you want, you can define that in the masking function. And you can just define, it automatically captures those masking functions for the column names. So this is how a data model looks like. This is from the Databricks website itself. So what it shows is for the bronze, silver, gold, and the data quality control table, you just need to define what is the source, what is the target data quality, and some utility columns. And using this, so let's say if there are some columns added in the source, you just have to go to these control tables and get those columns added. You'll also see like what are the delta-like features which helps us to do this. So this is a kind of a workflow. So let's say the landing zone is the bucket, maybe using ADS Gen 2 or S3. That is the place your data lands, let's say, in bucket format. Now from there, you have to make sure the data goes to bronze, silver, and gold. So the config tables are the notebooks where you have those control tables defined that we designed before. And through this, it will read all the rules for each and every table and help you move the data from bronze to silver to gold. Now let's understand what are the delta-like features that helps us to solve this problem. The first is ACID property. The reason people are moving from data lake to lakehouse, like Alex mentioned. The first property is the ACID property. So imagine we have this pipeline and there are batch data also moving on. Imagine on the first day when you want to do historical migration, each of the tables would be having 50 million records to 100 million records. And what if your pipeline fails in between, right? So when you want to start again, it makes sure there are no partial writes that will happen. So thanks to ACID properties in the lakehouse, which is missing in data lake and the data lake. Concurrent merges. So all the duplicate columns the problem can be solved using this concurrent merge. In US, like in California, we have CCPA policy. What if there is a disease which you have but you haven't told to someone else, but you got an email saying that, hey, if you have this disease, this is the solution. It means your data has been leaked, right? So what you can do is, there are ways in which you can raise a complaint, and this is under the CCPA Act. Now, what companies need to do is they need to delete this record of yours in the next 45 days. If you have a Parquet file, it's very difficult to do this, but thanks to Delta Lake, which helps. If there are millions of Parquet files, you can easily fill it in just one command. Batch and streaming, like I told, rather than maintaining Lambda architecture, this can help maintaining just a single table, and yet you can have batch and streaming both together. Scalable metadata handling. So the ones who are working in Hive, they know like if you do millions of transactions together, it goes to one database to read the metadata, which is not the case in Delta Lake. The metadata is stored in the JSON files, so that makes the queries very faster. And there's no metadata bottleneck over here. Schema enforcement and evaluation. We consider examples of Snowflake and SQL Server. If you cast a decimal number to integer in Snowflake versus SQL Server, you'll get different results. What if you are writing the business logics from different EMRs into Databricks? So to make sure the results are consistent, and we are talking about the lab results. It can improve someone's health and also deteriorate if the values of the glucose or any parameter is not captured properly. Right? So you want to make sure the data types is consistent. And at the same time, what if the column in the upstream has big integer and you're bringing it to a downstream table which is a different data type related to integer? You don't want your pipeline to fail, right? So the schema evaluation feature helps in that. So you can just enable the schema merge equal to true, which will take care of it. The time travel feature. There have been a lot of situations when you work on the production and yet you got some corrupt data from the source. And you executed the pipeline and already calculated most of your tables. How to restore, right? So in the Delta Lake, it's easy to time travel to previous version of the tables. And also, as you know, the Parquet files cannot be modified, it always overwrites. So it keeps on, like if you have millions of records, like we had 100 millions of records. So every time it kind of increases the storage cost. So vacuum does help in reducing that cost. With that I conclude. So these are some of the learnings that we saw today. The metadata-driven approach helps us in making the pipeline scalable. If you have 2 AMRs, I want to increase it to 5 AMRs, you just have to go to the metadata-driven table, the control tables, and add stuff over there. The Delta Lake feature, it definitely helps us to increase the performance and the quality, and the masking function that we discussed about, and the data quality stuff. So rather than writing different codes for all the tables again and again, imagine doing it practically, right? So that's not a scalable approach. So having that itself in the control tables, it does help. Cool. These are the references. Yeah. Thank you so much. Yes, sir.
I have 2 questions.
Yeah.
Really good presentation, by the way. So the first question is, I'm curious about how to maintain, what was the step you use to maintain the control table in a case like you have changes, dropping columns, adding new columns. How do you synchronize this to the system? How was the strategy used? And the second question is, if you can elaborate a little bit more, how do you unify the streaming and the batch together into one pipeline?
Yeah, sure. So, talking about the first in the control table. So, think of it like a CSV file, let's say. And initially, when you are refactoring the code or bringing the data into your system for the first time, you'll always have the list of columns which exist in the vendor, with the vendor, right? So, but in healthcare, the columns don't change that frequently, but still you want to make sure the system is scalable, so you can always get that added into a CSV, or if you can write a SQL to get that record added or updated, and that is how you used to maintain it manually.
Okay.
But it's a one-time effort that you do for the first time. And like for the second question, I actually added a screenshot here, not visible. So in the single data frame, it allows you to stream, and as well as in the batch format. Because of the Databricks, you can just write that code, and it will take care of both together. And even if people are, let's say, there are SQL queries or dashboards going on the same table, and simultaneously the records coming from the batch and streaming on the same table, it will not stop the performance of the queries that are going on the same table. Yeah, it's because of the ACID properties.
Okay.
Yes, sir.
So this still essentially code, right? So in some ways that means ideally you'd have a sort of like testing harnesses. What do you do for like making sure you haven't broken things?
Making sure?
Yeah, making sure that things haven't broken. So you have like unit tests. Like how do you do that sort of thing before deploying?
Yeah, so obviously we'll start from the lower environments, making sure the pipeline is consistent and stable, and then we'll push it to the production. But yeah, failures will happen. It's not like it won't happen. That can be because we are writing the stuff in the table manually. There can be some typos that can happen. So, but that failures won't lead to partial writes or commits on the table. And at the same time, if you do the try exception, I mean the failure thing, right? So it would get into the log table and the pipeline will stop. That way, it won't affect the other tables.
So you just run it in bronze, and then if it fails in bronze, then just
We won't execute the silver in that case. Yeah. So thank you so much, and I'm here for the presentation.
Great. So last thing, if you notice that in the two presentations we discussed the data lakehouse, we saw Delta Lake, we saw Iceberg, but we also saw that there are differences between different platforms. A lot of what Preet talked about is very specific for Databricks. We talked about how in Apache Spark different engines are different things. So we got a lot of questions over time. We started to do a panel on that. So please welcome Andy from OneHouse, will be the moderator. Preet will also join the panel, and Bruno from Box.